Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera for all of us. My name is Professor Setyawan. I'm a student from Isemantic University. Today I would like to present our research about brain tumor identification using Isemantic threshold method and morphological area selection. First, we start with the introduction. Image segmentation is part of image processing. The main purpose of image segmentation is to distinguish area of interest from an image. MRI or magnetic resonance imaging is medical technology that can draw our body into two-dimensional image. MRI can detect many diseases such as tumor, especially brain tumor. Brain tumor itself is known as life-threatening disease. It grows fast and spread wide on the host. From the explanation above, we decided to create a program that can automatically detect brain tumor and put mark on it so the medical personnel could take the right medication for the patient. As for example, a patient that diagnosed positive tumor, brain tumor especially, goes into the MRI machine. Then the MRI machine scans the tumor area from the patient and output an image that goes to our program, and our program detect the tumor area and put mark on it as shown on the slide, on the picture on the bottom here. And we hope our result from our program can help the medical personnel to take the right medication for our patient. Before doing our research, we read several research before. From 2016, there was performed a research about segmenting brain MRI image using anti-noise fast Isemantic. And from 2017, Ario proposed a method which combined fuzzy fusion k-means and spatial fuzzy c-means to segment brain MRI image. And from 2019, Aniket proposed a new segmentation method using modified fuzzy c-means with multiplication low frequency bias. As for our proposed method, the steps are shown on the slide. First, we load an MRI image, then applying pre-processing steps, and then we go to segmentation using Isemantic threshold, then applying post-processing to our segmented image, and finally we using Kenny edge detection algorithm to mark the tumor area. For our dataset, we took our image from Brett's 2015 dataset. We use 100 MRI flare images for our experiment. Each of MRI image comes with ground truth image which contain manual segmentation of the brain tumor performed by medical expert. We use the ground truth image to compare it with our segmented image for our performance measurement. Then pre-processing steps number 1 is convert the MRI image to a grayscale image. Then pre-processing steps number 2 is skull stripping process, which eliminate the skull bone from our MRI image to give a better look for the brain only and also the tumor area. For the pre-process step number 3 are noise removal and image enhancement. An MRI image contains noise which can affect the segmentation result. So we need to eliminate the noise. In this study, we propose a image enhancement process based on structural element. We also enhance the contrast of our image to achieve better look at the tumor itself. As you can see on the example of the image on the left, it's before we apply a noise removal and image enhancement, and the right side is after we applying noise removal and image enhancement to our MRI image. Then the image goes to segmentation process using fuzzy-semin clustering. The sequence of fuzzy-semin clustering is shown on the slide. For our study, we propose a segmentation method based on fuzzy-semin algorithm with a modification of thresholding calculation. The modification is meant to convert the segmented image into binary image that show only the area of the tumor, like on the example, the picture example on the right side. After the segmentation process is done, we go into post-processing process. Step number 1 is area selection. After the MRI image was segmented, we figured that sometimes the result of segmentation was disturbed with non-tumor area, as shown on the picture on the left. So we propose a post-processing step for selecting the biggest block of the segmentation, with assumption that is the tumor area, like shown on the picture on the right side. And after we select the biggest area of our segmented image, we use a canny edge detection to identify the boundary of the tumor area and mark it based on the boundary, like shown on the picture on the right. And here are some results of our segmentation process. And for our performance measurement, we use structural similarity index. Why we choose this method? Because we want to compare our segmented image with the ground truth image. So, the higher the SSIM value, it means both of our image, our segmented and the ground truth image, are the same, and also the otherwise. From our calculation for all 100 MRI images, we achieve an average of 0.592 in SSIM value. So the conclusion, fuzzy-semin is a powerful algorithm to cluster or segment an image, provide a persistent result of segmentation. The pre-processing and the post-processing steps are important to determine the result of segmentation. Skull stripping and nose removal take a major part of our study, and also the area selection to eliminate the non-tumor area after the segmentation is done. As for our proposed method, fuzzy-semin with threshold modification is quite reliable to segment the area of tumor given the high number of SSIM value that we have achieved. And for future improvement of this research, we suggest to develop segmentation for multiple points of tumor. That's for my presentation. Thanks for your attention.